This is the first lesson of the periodic table unit and the notes associated with it. So here, we are trying to understand throughout the course of this unit the patterns and the intricacies in which the periodic table has been set up, how it works, how to read it, and why it looks the way it does. So we're going to get started with just a little brief history here. Back in the 1800s, the first periodic table that was created was by a man named Dmitri Mendeleev. He set up the first periodic table, and this he had set up according to the atomic masses of things. In theory, it's a good idea. However, a lot of elements were missing from this table. Specifically, the noble gases were typically missing, and it needed to be refined. This is actually how it looked, too, when he created it. Shortly after, though, Henry Moseley updated it to the modern periodic table that we know, and the majority of, the biggest change of all of it had to do with the atomic number. And that's how this table is set up. We're going to explore why it looks the way it does, but really what is being outlined here is that the atomic number increasing is as you read from left to right. So atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's the foundation in which this whole table is aligned. Okay? So, modern periodic law says that atoms are arranged by increasing atomic number, which is what we just talked about. That's the big idea here. And they will show repetition of chemical and physical properties. And so within that initial setup of atomic number, we're actually going to see how chemical and physical properties are laid out throughout the table and how it becomes a lot easier to uncrack the puzzle that is presented to us. So, a couple of things that we need to talk about first, a couple of definitions so you understand how to read this chart. Because the periodic table really is a chart. Okay, but instead of using an X and a Y axis, or instead of using longitude and latitude, like on a globe, we're going to be using the word periods and groups. So periods are the things that go in a horizontal direction, right? So horizontal, H, horizontal being the long ways, right? And they are numbered on the table as 1, 2, 3, 4, 5, 6, and 7. The reason they were set up and the reason why a specific element is in the specific period that it is has to do with the number of electron shells that are in that element. So if we're going to use potassium, for example, potassium has a electron configuration of 2, 8, 8, 1. It has 4 total electron shells or energy levels or energy rings. And what that means is potassium will be placed right into the 4th period. 4 shells, period 4. The other term to talk about how to read this chart is the vertical columns called groups. They are numbered 1 through 18. Again, everything on the table has a specific reason for being the way it is. Elements in a group have the same number of valence electrons. And that is a similarity amongst them. So this is group 1, and things fall in group 1, because they have 1 valence electron. Okay. The middle section is a little bit different. It doesn't behave as simply as we want it to. So we're just going to ignore that for the moment. But over here, you have something that is group 18. And it turns out that everything in group 18 has 8 valence electrons. It's the reason why it's there. So between these two things, periods and groups, we're able to determine how many shells that are in an element, and we are also able to determine how many valence electrons are going to be in that element. And it makes it a lot easier to move around the chart. The last big idea before we start focusing on small details of the periodic table is the periodic table is separated by metals, nonmetals, and metalloids. Okay, a metalloid we can also call a semi-metal. But those 3 classifications of elements will be given to every element. They fall into one of these 3 categories. So what I have here is that metals will always be to the left of the staircase, metalloids will be on the staircase, and nonmetals will be to the right of the staircase. What I mean when I say the staircase is on the periodic table, somewhere off to the right. I'm just going to draw you a little, sketch here. Right, somewhere off to the way right. You're going to see this little staircase. This being the staircase. Every periodic table typically has it bolded or outlined in some way on it. And it's the divider of the metals on the left, the non-metals on the right, and the semi-metals on the staircase. And that's how we're going to start to decode the periodic table and understand why it looks the way it looks. In the next lesson, I'm going to talk about the differences between metals, metalloids, and nonmetals, and why things are classified as those 3 categories. Thank you for joining.